my name is George Fomichev. I'm the CEO and founder of Endurance Robots. It's a very early stage startup, and we make robots for education. So the reason that we wanted to organize and make this panel, just to talk a little bit about opportunities that open source robotics bring to people. So we feel that it's a great market opportunity right now to get educators involved into really practical robotic things, and we're gonna speak a little bit about this on this panel. So, right to me, Peter?
Yep. I'm Peter Zeno. I'm a PhD candidate here, and my thesis is actually in robotics. And it's sort of putting neuroscience and robotics together, and that's where my interests lie.
Hi, I'm Misha Salman. I'm faculty from the Mechanical Engineering Department at Stevens Institute of Technology in Hoboken, New Jersey. I primarily teach courses relating to robotics, product development, mechatronics, and control systems. And I also run a few outreach programs for younger youth robotics.
Hi, I'm Dr. Azhar. I'm from BMCC, City University of New York. I'm an assistant professor, and I have been with robotics for almost a decade. My research is in human-robot interaction, but I've also been involved in education robotics for almost 12 years now. I'm part of this competition called RoboCup Junior for high school students, and I've been organizer over there. I have been working towards creating curriculums for high school students and undergraduate students using robotics.
I'm Kang from Robotics University. I'm in charge of the design of engineering system for the industrial and system engineering. And every year we have like 10 to 15 projects ongoing, and many of them are robotic systems. So the robotic system we developed, including Amadel Crafter and robot for like pipeline inspection type of things. And basically we were trying to get the student involved with like robotic development.
Okay, contribution. So the first topic that we want to cover, so how do you guys think open source community for robotics should be created? Do you have some ideas? Do you have some vision of how open source community should be developed in terms of getting educators involved into this process? So we have already like resources like GitHub and Structables, Packaday, where you can share projects. But is it good enough for educators to get involved? Would you guys want something to be more advanced in terms of getting people all together? Like not only hobbyists and makers and students, but also professional professors and academics. So, Peter, what do you think?
Well, that's a good question. So you're looking at kind of a diverse crowd, so different levels of experience and what those projects would be. So you need to probably to categorize that somehow, and also make it rather simplistic to be able to get those things like on a web. Not some sort of bottleneck, but some good way of getting it out there.
So I am actually a big proponent of websites and services like Constructables and GitHub. I know that many of my students and student projects have either started based off of things that they researched on such websites, and also have added back towards those services. Now the question being, should there be essentially a higher level, and how could we achieve a higher level in the academic world? I think it's an interesting idea. I don't have particular thoughts on how to do that effectively, but perhaps it could be some kind of unification of those things with maybe like a super user type of interface. So we don't need to start from ground zero, but we can actually build off of it and have like the elite user mode or something like that for the more advanced topics.
Well, I have been involved with the high school teachers and also undergraduate professors and putting robotics in the classroom. And it's a challenging thing because robots are a lot of work for the students, for fun, but for teachers or professors, you have to create materials and make sure that robot works. So technology-wise, but I think creating materials for professors or high school students, right, with open source materials in mind, so you can give a package to them, right, and maybe start doing some pilot and then having some events around it. I think that will get them involved. So, so this way you have a model that can be expanded to other places. Let's say you come to my class and you give a package to me. Okay, here's a package you can use for teaching these materials using this robotics, and I use that, and then I can tell you how it works and stuff like that. We do a software assessment, we write papers and stuff like that. I think that will, get people more involved because they can see that it's work in a progress, and we are using it in the classroom. Okay, and especially for high school teachers, they really don't have time for creating new materials most of the time. So, like I'm right now working with 2 high schools, and I basically handed them the robots and the materials, and then say we're gonna run it for a year, and then I like to do independent from this whole process, and then next year you're gonna take over and continue from there.
So do you feel like lack of curriculums for your classes, or right now a lot of materials that you can get from researchers? Do you think that you need some sort of like starting point where you know that you're going to teach like about microcontrollers and DC-DC converters, or is everything is okay that is provided on the Arduino website or Raspberry Pi?
Well, I think the challenge here is that when we teach in a classroom, it has to be customized, right? So we all have different needs, right? So when you go to a website, you see something you can use, right? So we need to have a way to kind of work with a teacher or professor to make sure that their needs are met, right? And then we have some setups. And as we build this open source environment and also open source curriculum maybe, right? So people can go and say, okay, you want to teach this topic, here are some materials over here you can use, and the whole setup is here. And these are the professors used before, or these are the teachers used before, and that works. So that kind of setup would be nice, I think. That's what I felt like, even for Lego robotics, and this has been around for almost over a decade, right? And if so much materials there, but if you go online and then try to find something, you're gonna be like, okay, this doesn't work for me, this doesn't work for me, right? So you have to be. So we worked on this for a long time and creating materials for specific classrooms and topics and stuff like that. And a lot of the stuff probably we can take over and then put it in for the, let's say, open source robotics, because they overlap the topic-wise, right? So instead of using Lego robot, we're going to use an open source robot to teach the same topic. Then how do you make that happen, right? So it's going to be translating from those robot to this robot and then make it work. Yeah.
Robotics is such like a interdisciplinary like a field, and I would say, first of all, when we talk about robotics, and what type of robotics we are going to use for open source, because I saw here it has a HUA, and then we have like a joint robotics and the robotic arm, and then we have unmanned aircrafter, and which one you really want to let them to work on. Right now I have all kinds of robots that let them work on. For some of them, using the robotics arm to do the picking, and then for that project the knowledge they need to have, first of all, is kinematics, planning, motion planning. And then, in order to grab the things, then you have to have a very, very clear understanding of how the arm to work, and then vision system, and then the many stuff you need to integrate. And then for HUA is totally different, right? SLAM, and then and also the hardware design, because this is a 4-wheel one, and what was a 3-wheel one, and then also has a lot of components there. So it's a very broad area. When we talk about open source, and we may have to provide a boundary, because after, and also for hardware, and do you want a student to use in the get the hardware from outside, or make to make by the components by themselves, and then if they have to make them by themselves, the machining, SolidWorks, and all those things has to be there. So it's I'm teaching the design of engineering systems. So the first semester we cover all those topics, but I have to say, most students are not ready, but then getting exposure. And then the second semester, we have to push them. And how to push them? There are many ways. And one is, if you cannot get done, and then you get F, and then everyone work very hard. But if you tell them, okay, yeah, it's just a hobby, and then you are going to see very shabby stuff. So really, it's the goal, and then it's a goal. Will determines what kind of course you want to offer. I give I ask a mechanical engineering student to develop robotics. I ask a computer science student working with me to develop robotics, and I have industrial engineering student working with me on. So they all have different background, and have different needs, and it's going to be very, very challenging. So when we talk about the open source, we really have to make some a constraint or boundary on that. So are we talking about HV or US or robotics, joint robotics?
The thing is that you can do open source, but then divide them into different categories. Where you have ground robots, you have, let's say, UAV, you have probably some spider-like robots. So you make different categories, and it's only for mechanical part. Then you go deeper inside about software, where you have ROS, where you have solutions for Arduino, and you can actually find whatever you need. So what do you guys think about peer-to-peer review? Is it something that people would really need to have? Because, for instance, you make your project, or your group of students made a project. So how you present it to public, of course you can public it, make it visible on your website, but if people do not visit your website, or they do not do special search, how they might find it. So if they are not subscribed to your mailing list, so they don't get these updates. So do you think of course you can, like I said, upload it on Instructables, but then it's also not like a review. People may give comments, they can click a button that they made it, but what about peer review, when you get some academics involved and reviewing, say, yeah, it's a nice idea that you made it, like Peter is working on autopilot, autonomous vehicle, but he's not using LiDAR right now, right?
Right.
So he's using a little bit different technologies, and probably if Peter make it on this resource public, so then some can come up with the idea, hey, you can use this LiDAR, they're very cheap, they're affordable, and here's a software that you can use on your robot. Then this whole society will get additional knowledge. So what do you guys think?
So almost like a forum of some kind.
Well, yeah, probably like forum, but still you need a review when you have a final project.
Right.
So for instance, when you did it, you probably, you just want an opinion or evaluation from other groups who say, yeah, it's really nice, so we want to take it as another step because you made something advanced. So right now what I found out that a lot of people, they start from the scratch all the time from the very beginning. They take Arduino, they take board, they do soldering, but what if it's already there and they know that it's well written, this is like a new protocol. So.
Well, yeah, the only thing is, people go and do it by scratch, but that's a good way of learning.
Yeah, sure.
And sometimes you don't want to just you don't want to just hand out the product. Because, I mean, unless it's an essential part of, they want to go on to designing something else that's not out there or whatever, then yeah, this module portion would be great to just add on. So my project is just like a lot of research. It's, so that, you know, you're skimming the web for what will work, you know, you try out the code, and I think, I don't know.
Yeah, but it takes a lot of time.
That feedback.
For instance, we tried with OpenCV, we couldn't do that. Why on our robots we use Google.
Right.
So what if you put a problem and then people can help you with different, it doesn't mean that you do not get knowledge, but
Right.
you don't waste time on checking something that is not working or not perfect for your particular need, because it takes time to find it too.
Yeah, the only thing I would say is that when they get in, when an engineer gets out into the field, what they have to do is, they can't find a project that's exactly the same as theirs. They have to do the research. And they have to research what works best, research, you know, sonic sensors versus IR sensors, distance sensors and all that, and what code works, what code doesn't work, you know, get feedback. So, I mean, that in that part, it is very difficult, but that's what reality is when you're out there as an engineer. I mean, it would be great if you could have more complex things like the robot operating system and more visual pattern recognition and that sort of stuff that you can more easily, because I've seen stuff for Raspberry Pi that, you know, you go through this, try that, try this, try that, and it ends up not working or whatever, you know.
So it sounds like what you're describing seems to become a fusion of a wiki page with something like a GitHub or Instructable format for delivering material, but also including some kind of open access journal, such that you have some form of peer review, but in an open access format, you would allow people to log in and just check without necessarily registering or anything like that, so that the general public can get access to it. Now, kind of backing up a second, I think that the whole question in general about, is there a need for such a thing, for such an open access format for, say, educators, and how do you approach it? It's kind of its own optimization problem, because you can look at it at the very broad, big picture, higher level. Well, here are the steps you take when you want to solve any form of engineering problem. You need to look at what the problem is, what are the needs to solve that problem, what is available to allow you to solve that problem, and what options do you have, what concepts can you develop, be they physical or just hypothetical, such that you can address those issues and then move forward with analysis and so on and so forth. So I think that maybe it could be set up in a hierarchical manner, such that you have this very, very general approach for someone like a high school teacher who may not have any form of engineering background but wants to bring this to their classroom somehow. So that it's basic, well, here's a problem, what are the real points in the problem, how do we break it down, address that in stages, but then you can go a little bit deeper and say, well, okay, we know that we can solve this problem using a ground-based vehicle, for example. Here are some of the concepts that we need to consider. Well, we can start at the very, very basic level where we need to.
So IEEE, I believe IEEE, there is a group of people who are trying to develop the, what's that called, the robot ontology type of thing. So to work on that. So then people can, you know, use the same language to talk to each other. Otherwise, there's so many like different type of robot, and it's going to be very tough. So I know last week or 2 weeks ago, submitted like joined the proposal on this type of things that I'm going to present. I think that, well, I would say the idea is good. At least give people with a different background to same page. Otherwise, the software guy and look at the hardware and then come up with some language, weird language, and then the hardware guy brings some like a very, different type of language to the software people, and then they're not going to communicate well, and then it makes things very difficult. If there's some common language, then at least, it's going to be easy for them to integrate with each other, and they don't have to, stuck with many, unpredictable like a error. And another thing is, basically, I'm working with a different student with different background. So computer science people, they can do mechanical stuff if they're really into that. So I have 2 computer science students right now. It's design the unmanned aircraft stuff, and then the hardware. Because we are going to attach different type of things and then do different applications, so they build it by themselves. So the key is really, first of all, they have to have interest, and so different level people will really have to give us different solutions. Good student, average student, and then just beginners. And then you have to have a different solution for them. And then the first thing we need really is a common language. Yeah, that's my suggestion.
Yeah, so it sounds like maybe one form of a solution, maybe that you have the hardware and software developed such that you can make available the entire functional system. But depending on what your interest is, if you want to develop the AI engine, so if you want to further develop a different hardware platform, if you know all of the modules function, you could treat each module as a black box.
Yeah.
I know these are the ins, these are the outs, this is the performance, how it does it, let's not worry about that. And depending on what it is that you want to achieve, you can remove one of those modules and say, I will redesign this module. But again, it becomes a daunting task to make it applicable at all of those different levels for the introductory student and the nominal student and the advanced student, the graduate student, and so forth. But you have to start somewhere.
I think the challenge here is that what's your objective, right? The teaching objective. That's the first thing, right? So if you're we're doing research with a student, that's an awesome thing to be. I think it's a collaborative environment. You have a computer science working engineering student, right? And this is great, and they can learn from each other, and it's a fantastic environment. And research is sometimes open-ended. 1 semester, 2 semester, years, right? Years and years. But then you go to the classroom setup, right? I have 12 weeks, right? And then within the 12 weeks, I probably learn robotics maybe for 3 weeks. So now, how do I make things happen in 3 weeks, right? So you see, you have to figure out what's the constraint you have, and then kind of serve this audience. I think that way. So they have that kind of setup. And you can have a robotics class, for example, if you have the whole semester. And then you can basically create materials for them, and then go to high school, you have a different audience, different objective, right? So I think starting to have materials will be really useful for both for curriculum, for hardware and software, and then have a model. Like, okay, this work in this classroom, this work in this research project, this work on this thing. So if you're going to a point, having this peer reviewed thing, like, okay, I downloaded something, okay, from his website, and he created something, and then I can say, oh, it worked, thank you, and I'm adding something to this. So my student created this, I uploaded that. So something like, if you think about in Khan Academy, I think is doing that, or like Scratch, those open source environment, where you can have a game someone made, and you can do a spin-off. Right? So you just click on it and then spin off that thing and then create something new. So there's nothing wrong with someone did something, giving them the credit, and then you adding something to it and learning from the whole experience. I think having that kind of stuff is very possible in this open source environment, because we can do a spin-off of your project or his project or my project, right? And then you can create, and that kind of opens up so many things you can do. And having this community where you can have this website where you can have spin up different things, I can maybe that kind of setup will be really useful. And then having a place where you can buy the materials is very important. I think I cannot stress this any further, because when I look at a project, I say, oh, this looks awesome. What do I need?
Exactly.
Right? And I look at this thing, I might need this, I might need this. Looking at the picture, I can figure this out. So having like a professionally set up, buy this thing, here's the package, click on it, this is gonna cost you $10 or $20. Arduino does a good job with that kind of stuff sometimes, when they have the projects like that, you can go and buy stuff like that. I think that's great. Adafruit website, I think, is pretty
Smartphone as well.
right. So they are good at that. But I think that's important that when my student wants to work a project, I said, find a project that has all the materials so we can know what to get, because you don't want to get stuck in the middle. I don't know what to do here, right? So I think that's another challenge, I think, in general. Yeah.
If I could add just one small thing to that. So not in an open source forum per se, but MathWorks, who generates MATLAB, Simulink, I'm a big proponent of their software, I use it in a lot of courses. They have a structure for this already. And I've actually used their materials where people could submit for funding to develop a course based on their software. And they have entire curricula available where I've downloaded robotics courses where we use X platform available commercially off the shelf. And we went through these types of exercises with the project. And in a similar manner to what's being described, people will work with that as a starting point, and then, well, I took this and I wanted to focus more on the SLAM element. I wanted to focus more on the higher level, how do we address the problem element, and people show how they've expanded upon it, and they can leave feedback. But because it's already been funded through a granting agency, so to speak, it is to a level peer review, because they don't want to put their name on something that isn't worthwhile. So there is a mechanism that does exist, but it's not open source. So maybe taking that as a starting point could also work.
It looks like it's all about software. When you talk about this toolbox, it's more software oriented.
Mm-hmm.
So basically, you want to get the hardware ready.
Mm-hmm.
So that's basically right.
Generally, I mean, I'm a mechanical engineer through and through, but in most of my robotics and mechatronics related courses, it is the software that's being developed. Now that could be partially biased because coming from a mechanical background, we come in with the expectation that you already know how to deal with mechanical systems, and this is where you need to grow. But there is a need for people who don't have a mechanical experience or aptitude, but they understand the programming, they understand the logic, and they want to be able to apply it to something.
So yeah, I'm happy that we jumped to software thing. So we are also considering that in some cases, hardware and mechanical engineers, they require more advanced software solutions to install and to use on their robotics. So what we have now is like ROS, where you can do all kinds of measurements and data collecting and data analytics. But what about some sort of artificial intelligence? So what if we can set up something like a chatbot, real chatbot on the robot? So for example, you create something and you need this robot to be controlled. So you don't need to create your own voice recognition system if you want to control it out of voice. So you can use actually Google to go voice to text, and then you can do search for keywords and do some movements on what command came. So what do you guys think about taking some artificial intelligence from chatbots into robotics field, so that you basically take anything, for example, like Hello, Google Hello, they made their own chatbot now, Google Assistant, so you can take some existing projects and products and install them on the hardware. So do you think that it will bring more software engineers into this space, because then they'll see the final objective where this chatbot can be used to do everything?
Yeah, I just want to add two things, because I think we're running out of time. So I was wondering if you want to ask questions.
No, I think we'll have like another 20 minutes or so, so we'll
Okay.
start a little bit later.
Okay, and the second part of what you're saying becomes down to the module part once again, as to what do you want to add to the system. And the thing that I get worried about is that you get companies that they want to sell their product, and they want to be able to make it modular, which is good, but then they kind of jack up their price, and it becomes a very expensive entity that, okay, well, if you want to work on software, it gives you all the hardware means and ability to add voice recognition and stuff like that. Hopefully there's a way of interfacing or getting into that information to be able to do what you want to do. I'm not sure how that would, because I'm not sure of that whole chat box thing. But the only thing I worry about is you get these companies that just jack up prices, like mobile robots like that. It's so simplistic, yet you can spend $150 or more, and it's just, you know, it's just kind of crazy to me. So.
I think that there's room for implementing that level of AI, and honestly, anytime you can bring something new or different into the world of robotics or anything else, you're going to get more people's attention and get people who may not have otherwise been interested. So I think there's room for it. But I do have to say that is not my area of expertise.